Today's lesson is over slope and rate of change. The slope, usually represented by m, of a non-vertical line is the ratio of a vertical change to a horizontal change. You covered this fairly extensively in Algebra 1, but it's very important and it's a concept that there's still a lot of confusion on. So today I'm going to hopefully clear some of that up. The mathematical definition of slope is m equals y2 minus y1 over x2 minus x1. In other words, this is just the differences in y's divided by the difference in the x's. That's all you're doing. It's not overly difficult, you just need to watch your signs. What does trip people up is the larger understanding of slope and the different ways we refer to it. There's a lot of different ways. You're going to hear it spoken of in math. You will hear it's the rate of change. You will hear the rise over run. Sometimes you'll hear it referred to as the difference in y's over the difference in x's. If you were in any science classes, this one may be familiar. Delta y over delta x, or the change in y over the change of x. It's the vertical change over the horizontal change. And if you really get desperate and you have to remember this somehow, it's the up and down difference over the left and right difference. But hopefully we can move beyond that pretty quickly. I want to go back and revisit our formula a little bit, clear up some things, and explain it in a little more depth than you did in Algebra 1. Our formula is given as y2 minus y1. It does not matter the order you use the x's and y's. Let me show you what I mean. If we have x1, y1, and then we have x2, y2. The trick is to be consistent. Whichever pair or variable you decide to use first, be sure you do the same thing with the y's. So you could say y1 minus y2 over x1 minus x2. You just need to be consistent. Another thing our definition points it out is the slope of a vertical line is undefined and the slope of a horizontal line is 0. I want to illustrate this in a little bit more depth, hopefully in a way that will make it easier for you to understand and remember later. Let's start out with a vertical line. A vertical line would look like this. The change in this case is classified as undefined because the changes in y over the changes in x give us something over 0. We can't divide by 0. To prove my point, let me give you 2 points on this line. We have the point. We're going to say this is 3, 2. Let's use this point. Again, it's going to be 3, but this time, let's say it's negative 2. Go through and use your formula. We're going to say the slope equals y2 minus y1 over x2 minus x1. So we have negative 4 over 0. That's undefined because we cannot define by 0. If you have a hard time even now remembering this, think about it like this. What if you were a skier and you are going skiing? This is your ski slope. Here you are, the happy little skier on your big O skis, and you're getting ready to go down this slope. This is not just a black slope. This is a triple diamond black, free flying, come in on a helicopter type slope. You're getting ready to jump off and go just like that. Think about it. You're standing on the edge of the slope. Your ski tips are out over the abyss. Do you know what's going to happen after you jump? You might end up dead. You may end up flying. It is completely unknown. That's a way to remember an undefined slope. Horizontal slope, a little differently. Your horizontal line is going to look like this. The slope of this one is 0. These two are easy to get confused unless you remember a few things. Let's look at it algebraically. I have a point right here. Let's call this point -2, 2. I have a point right here. To keep it simple, let's call it 2, 2. Our definition says slope equals y2 minus y1 over x2 minus x1, or 0 over 4. We can have a 0 in the numerator, we just can't have a 0 in the denominator. Therefore, our slope is 0. It is defined, but it is flat, or there is no change. Think about it like a gas price. If the gas price stays the same for a week, there is no change in it. So the change is 0. Now, another way that might help you remember is this. Many of you have been through the wasted program at the high school with us. Whenever someone dies in a car accident, they come on the PA, they play the super annoying crash noise, and we get to hear the heartbeat. And what does the heartbeat do? It goes thump, 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 What occurs during that? So the heartbeat's going, and then you hear what? That. What is that when you didn't hear it? The patient is said to have flatlined. When a patient flatlines, they have no heartbeat. When you have no heartbeat, you're dead. So maybe that's kind of a gross analogy, but maybe it will help you remember it. You will be asked to classify lines using slope. There are 4 different classifications. The first one is a positive slope. It rises from left to right. Now when you're reading a graph, which is kind of a strange term, but you read a graph just like you read a book, which is left to right. Makes things a little simpler. It's a positive slope. It is rising. Some real world examples of this. Think about your bank account. If your bank account is going up, that's positive. Our second one is a negative slope. It is falling from left to right. It is going downward. Again, with your bank account, if your bank account is going down, that's negative. A zero slope, we just spoke about this one earlier. That are your horizontal lines. A zero slope is defined and it's m equals 0. It is unchanging. An undefined slope means it's vertical and we have no means to quantify that. That is something divided by 0. It's undefined. It's when you're about to jump off the ski slope and don't know. Of course, when I ask you to classify lines, you can always plug them into your calculator, look at the graph, and visually tell if they're rising, falling, staying the same, or having no change, which is 0, or a vertical line, which is undefined. But you also need to know how to do it algebraically. So let's go over that a little bit. If you are given the point, -5, 1, and the point 3, 1, to find the slope, we use our formula y2 minus y1 over x2 minus x1. Often you're going to be asked to classify lines. Of course, you can plug these into your calculator and visually look at it, but you also need how to do it algebraically. So that's what we're going to work on now. If you were given 2 points that create this line, -5, 1, and 3, 1, I want you to classify the line as positive, negative, undefined, or 0 slope, or horizontal. So we're going to begin by using our formula, which is y2 minus y1 over x2 minus x1. So y2 is 1 minus y1, which is 1. x2 is 3 minus x1 is 5. This gives us 0 over 8. As our top number is 0, means the slope is 0. A slope of 0 is horizontal. You could graph this and check. We have the point -5, 1. We have the point 3, 1. It's going to look roughly something like that. Let's do the same thing with this problem. Classify the points as rising or positive, falling, negative, no slope, horizontal, or undefined vertical. Use your formula, which is m equals y2 minus y1 over x2 minus x1. Our y2, -4 minus 0. Our x2 is 2 minus -6, which gives us a slope of -4 over 8. We want to reduce this to -1/2. A negative slope is falling. So that's a negative, and it's falling as we go from left to right. Another example, 4, 6, and 4, -1. Using your formula to determine slope, we have -1 minus 6 over 4 minus 4, which is -7 over 0. We cannot divide by 0. That's our ski slope. We don't know what's coming next. That means this line is undefined. It is vertical. Now, right now the algebraic method's working out fine, but at some point you're going to move a little further along in math and you're going to start realizing some similarities and differences. Let's look in this problem right here. What is alike? Our x's are alike. Well, we noticed when we went through all of our algebra, it ended up being vertical. And if you think about this, if your x's repeat, it is not a function, which meant it was a vertical line. So with a little practice, you can get used to recognizing these without having to do quite as much of the algebraic work. Now, back to our previous example, actually our first example. Let me rewrite that one for you. We had -5 and 1, and the point was 3 and 1. What is alike? In this case, the y values were the same. When the y values repeat, it's still a function, but you know it's horizontal. If it's horizontal, the slope is 0. So with a little practice, you can get used to finding these special patterns without having to do as much of the algebraic work. All right, let's discuss some specific type of lines, and that would be parallel and perpendicular. Parallel lines are perhaps the one people are the easiest to recognize. These are your railroad tracks. Two lines in a plane that do not intersect. They have the same slope. Algebraically, this is your thing. The slopes are alike. So in this example in the center of the page, if you notice, whatever those two slopes are, they have to be alike. If you look in our equation, our first line is 2x, our second line is 2x plus 5. The slope is the same. That means they are parallel. This can be really useful when you are working with lines, and algebraically it can allow you to make assumptions. Two lines are perpendicular if they intersect to form a right angle. What I want you to be careful is, just because something looks perpendicular, it may not be. We need to prove that mathematically. On your calculators, they don't always use a square window, so sometimes things are perpendicular and don't appear to be. So you have to be a little careful of that sometimes the examples and the visuals aren't always what you think you're seeing. Perpendicular lines have slopes that are negative reciprocals. Now let's just think through this logically. We know, just looking at the picture, that the slopes are not the same. In fact, we want the slopes to be opposite. One is positive, one is negative. So the signs have to be different. That's your first clue. And people are pretty good about this. One has to be positive, one has to be negative. The other thing is if you have a slope of 2, you want something that makes a 90-degree angle with that. Or you want its inverse, or its reciprocal. So we use the reciprocal of the slope. So once you find the reciprocal, then you need to find the opposite slope, and you will have a perpendicular. When you multiply perpendicular slopes, this is a good way to check. When you multiply, and that's the symbol for perpendicular slopes, you get -1. Quick way to check, not a lot of work there. You can do it in your head super fast. However, perpendicular can throw you a curve. What if we're working with 2 lines that do this? What do you know about the slope of this line versus the slope of this line? Well, line 1 has a slope of 0. Line 2 has a slope that's undefined. There is no slope. These are negative reciprocals. 1, you can see it visually. 2, if you look at the math of it, you have 0 over some number times some number over 0. And when you multiply, you're going to end up with perpendicular slopes. Let's practice a little bit. There are 2 lines, one through the points, -2, 2, and 0, -1. A second line through the points, -4, -1, and 2, 3. Tell me if these lines are perpendicular, parallel, or neither. To do that, you need to know the slope of each line. To find the slope of the first line, we're going to take y2 and subtract y1, and we're going to divide that by x2 minus x1. So my slope is -3, and 0 minus a -2 is 2. On my second line, we'll repeat the process. The slope is y2 minus y1 over x2 minus x1. 3 minus a -1 is 4. 2 minus a -4 is 6. And that can reduce to 2/3. Now, the question is, are -3/2 and 2/3 negative reciprocals? Are the signs opposite? One is negative, one is positive. They are. Are they reciprocals? 3/2 and 2/3? Yes, they are. So I would call this perpendicular. To check, let's multiply. We know that m1 times n2 should be -1. -3/2 times 2/3 gives me -6 over 6, which is -1. So these lines are indeed perpendicular. All right, let's look at another problem just to be sure we're comfortable with what we're doing. Again, we have points that create 2 lines. We want to know if the lines are parallel, perpendicular, or neither. So let's find slope. The slope for my first line is y2 minus y1 over x2 minus x1. And that gives me a slope of 5/2. Moving on to my second line. My slope is 4 minus 2, or y2 minus y1, over x2 minus x1, or 2/5. Are these perpendicular? Are the signs opposite? They are not. So then we know right now they can't be perpendicular. They're not parallel because they're not the same. If you want to do a last check, remember m1 times m2 should be negative 1 if they are perpendicular. 5/2 times 2/5 gives me 10 over 10, which is 1. These are not, they're not perpendicular, they are not parallel, therefore they are classified as neither, which seems an odd answer, but there you go. Hopefully this has cleared up any questions you may have on slope. If you have any further questions, please see me.